All right. Good morning, everybody. So we are going over your topic F exam. I'm going to show you an example exam, and you might see similar questions on your actual exam. Okay, exam. I'll say exam again, an exam. I'm going to go over some quick notes to help you out. So I'm going to post this on your Canvas page in a little bit for review, but it's recommended to have a piece of scratch paper or a piece of line paper and say on number 1, Atterbury said this. On question 2, Atterbury said that, just to help you out. So it says, given the following non-regular quadrilateral, find the measure of the unknown angle. Okay, so you've got a 4-sided figure. Okay, our sides, number of sides equals 4. We'll say something like n equals 4 is very common. Okay, and there's an equation that says n minus 2 times 180 equals the total amount. Okay, so what you want to do is take all of these side lengths plus the one you don't know. So it's like that piece plus that piece plus that piece plus this piece. Okay, and that will add up to whatever this answer is, right? 4 minus 2 times 180. Okay, you're going to plug this right into there. Okay, 4 minus 2 times 180. What does that equal? And that's going to kind of be your total here. Those 3 known sides, so this plus this plus this, yours will probably be slightly different. Okay, and when you solve this equation, okay, and you get down here, x equals something, that will be your answer straight down here. Okay. All right, question 2. This is going to be the same exact question. Okay, this time our n, it says pentagon, right? 1, 2, 3, 4, 5. There's 5 sides. So it'll be the same thing. Okay, n take away 2 times 180. That equals the total amount of degrees your inside, your interior angles will add up to. Okay, it's the same exact problem. The difference is it's 5 sides instead of 4. So it'd be the same thing. You can say all 5 of those sides. So 1, 2, 3, 4 known sides plus the unknown side, we don't know what that is, will add up to whatever the answer is here. Okay, when you solve this, right, combine your like terms, it'll be that, you'll solve it using some algebra, and that answer will be your final answer there. Okay, I don't want to go too fast, but I want to make sure you guys have plenty of time to do your test. So I'm going to go ahead. I'm going to move on to the next question, which is question 3. And as you see, 1 and 2 are solved the exact same way. The difference is it's 4 sides, and this is 5 sides, right? 4 sides, 4 angles, 5 sides, 4 angles. These 4 angles will add up to a different number than these 5 angles. Okay, but every 4-sided shape, like a square, a rectangle, trapezoids, okay, or just other 4-sided figures like this, always add to the same amount. Every 5-sided figure adds up to this same amount, okay? It's kind of like every triangle adds to 180, right? It's exactly the same. All right, question number 3 is going to be the same as question number 2. The difference is there's some algebra. So it'll be the same amount, whatever it equals for the 5 side, okay? Whatever your 5 minus 2 times 180 would add up to, but instead it's got an extra step into there. Okay, when you add your 5 pieces together, 1, 2, 3, 4, plus this 2x minus 5, or whatever yours says. Okay, I'm putting 2x minus 5 because that's what my example says, and that's going to add up to whatever that was. Every 5-sided figure, 5 sides, 5 angles, adds to the same amount of like a total amount. Okay, remember, triangles always add to 180. 4-sided figures always add to blank. 5-sided figures always add to something else. 6 sides adds to something else. But it doesn't matter the style, like if it's like perfect or not, right? The regular shape or not. Every 5-sided figure will add to the same amount. Okay. Now, when we get this, now it's going to be a little bit more algebra involved. But when we get our final answer, okay, that is our x value. That's not our final answer. Okay, and so there's a few ways to solve for this. The way we kind of did it was we did the A lot of times we call it back substitution, like you substitute the value back into your question. So after we solve for x, since we've got like this little mini equation here, 2x minus 5, right, the 2x minus 5, we want to say, well, what did the x value equal? And what is that answer? Okay, that answer right there will actually be the degree measurement. Okay, there's other ways to solve it, but I'm just going to go over that basic way since that's kind of how we did it throughout the practice. Okay, so what's one extra step in there? A little bit more complex because it's 2x minus 5, but let's use our resources, okay? So something like this, when you type this stuff in, you can use your algebra calculators, okay, whether it's on a phone or a website, but there's algebra calculators to help you out if you struggle with this algebra part, okay? Find the number of sides for a regular polygon whose interior angles each measure 3 times each exterior angle. I just realized we're not going to do that question. I'm going to block that one out, so don't worry about this. Okay. Okay. So this one, just get rid of number 4. I apologize. Just skip that question, guys. I thought it was part of the other set. That must have got kind of put in there accidentally. So now you've only got 9 questions. Sweet. You get free 10 points on the test just for starting the test. If you do this test and you miss everything, you'll still get 10 free points. Okay. That's my apologies. Number 5. Okay, number 5 is this right here. It says the interior angle of a regular decagon. Okay, we didn't go over all this vocabulary, but if you struggle with stuff like this, decagon, if you type that into Google, okay, use your resources, this is 10 sides. Deca, like decade. It's exactly like decade. Decade's 10 years. I think everyone knows that, right? Like this decade, that decade. It means for these 10 years. Okay, so yours might be a little bit different. Yours might say 15 sides, 20 sides, you know, octagon. If you don't know the word, seriously, go into Google, have a different window open, search that word, okay? Decagon would be 10 sides. So that means my n would equal 10, okay? So what you do for a question like this, right, is you say, well, the equation n minus 2 times 180. This equation still comes up, and you will get an answer, okay? Let's just say I get like 1,000 for my answer. Okay, it's not going to be 1,000, but let's just say it was. And then it says, find the measure of an interior angle of a regular decagon. Okay, when you see regular, that means all the sides are the same. Okay, and on your last test, you had a question about a regular triangle. And what I said was, for a regular triangle, right, all triangles add to 180. And a triangle has 3 sides. So if you divide by 3, we got a regular triangle always adds to 60. Okay. But for a question like this, it's not a triangle. It's like a decagon, like 10 sides. Maybe yours is like an octagon or a pentagon or something. You first figure out what's the total angle measurement for that shape, for that polygon. And then you divide it by the number of sides it has, like 10. So if I divided this by 10, it would be 1,000 divided by 10 equals 100. Okay, and that would be my answer. It's not 1,000, so I'm going to let you guys kind of figure that out. But whatever this answer is, divide it by your side. So I guess there is an equation you can use, which would be n take away 2 times 180, and then divided by n. So this actually is, I just kind of came up with this. This is it's not that difficult to kind of really see, I think. But is the number of sides minus 2 times 180. And then you divide by how many sides it had. Okay, I do foresee maybe potentially some issues with this. If you guys have questions, we will review this again on Friday, and we can help you guys out individually if you guys have more questions, okay? When it says round to the nearest tenth, that just means if it was a decimal, you would only do 1 decimal, okay? So it would be like, I don't know, I'm just going to use letters like X, okay? If it says 10th degree, that's just that 1 decimal place. So if it has more decimals, just cut it off and put that 1. And if you guys know how to round up or round down, please use that appropriately, okay? It just means to go to 1 decimal place past the decimal, okay? That's your 10th. All right, moving on. Find the figure below the parallelogram, find A. Okay, all we are is solving for letter A. So when you have a parallelogram, okay, the opposite angles, like the opposite sides, are the same, right? These lengths are the same. those widths are the same, kind of like a rectangle, right? The opposites are the same. Okay, the same is true for the diagonals. Okay, the degrees are the same. So we got to say this is equal to that. So on this one, I would say 9a plus 9 is equal to 14a take away 6, and I would solve to get a using some algebra. If you struggle with the algebra, use a website like, that's got an algebra solver to it. Plug this stuff in. This side equals to that side and solve it. Okay. All right. This is number 7. Number 7 says the figure below is a parallelogram. Find Z. Okay, so just like I said, the opposites are the same. There's a cool thing that kind of comes up is that whenever the sides are not opposites, but they're actually adjacent. Okay, adjacent means they're next to each other. So either they're both on the top, or maybe yours are both on one of the sides. Okay, or maybe it's both on the bottom. Okay, those are called adjacent. Why? Adjacent means that they're next to each other. Okay, adjacent. It's going to come up a lot when we get to more advanced triangle stuff later this year. Okay, adjacent. Adjacent means they're next to each other. Okay, those are called opposites because they're not next to each other. They're away from each other. They're opposites. These are next to each other, so they're called adjacent. Adjacent add up to 180 degrees. Okay, so that piece plus that piece will add up to 180. So for mine would be Z plus 130 adds to 180 and solve. Whatever the answer is, so like Z plus 130 adds to 180, solve that, and that answer is simply that answer right there. Okay. All right, a few more to go. The figure below is a parallelogram. Find A and B. Oh my gosh, this looks so complex, right? Right. So on a problem like this, I know it can be kind of difficult to see. Let me see if I can't grab. Here we go. So this is a parallelogram, right? It tells you. It is telling you. It is telling you. Parallelogram. Okay. So a parallelogram, just like when I said the opposites here are the same, you see how you kind of draw those lines and they kind of like cross. Those lines are called diagonals. Okay. And these diagonals, this line that goes from D to B, that's cut in the middle by P, okay, those side lengths are actually the same piece. It's cut right perfectly in the middle. Like if you've got a ruler that's 12 inches, right, of 1 foot, which is 12 inches, and you cut that in half, that would be 12 divided by 2, which is 6. Okay, one side is 6, the other side is 6. It's cut perfectly in half. Okay, if it was, let's say, 10 feet, let's say you had a string that's 10 feet long and you cut it in half. Okay, each piece of the string would be 5 feet and 5 feet because you cut that 10 feet piece of string in half. Okay, so that means that this piece and this piece, okay, you see this and this are the same exact length. So I would say to solve for letter A, I would say 2a plus 4 would add up to 4a plus 6. I would do my algebra, okay, and solve my equation, and that would be equal to a. That's half of it, and believe it or not, the other half is the same thing. Okay, this piece over here, okay, and this piece over here are also the same length. That means that this piece, 3b minus 4, adds up to 4b minus 7. Now yours, like I said, will probably be some slightly different numbers, and that's okay. But use your algebra or an algebra calculator to figure out your answer. And that will be your answer for B. All right? So it's like 2 little mini algebra equations, but you got to know that the pieces that are like this, the 2 red pieces, are equal, and that those 2 green pieces right over there would also be equal. Okay, 2 more to go. This one is the same, but probably a lot easier. Okay, this looks a lot easier than number 8. Okay, those pieces there, right, are the same. These pieces here are the same. So if this was yours, x would equal that, and y would equal that. Okay, and just literally that's it. Okay, it's like this is that should be like a 10-second problem, and I got confidence you guys will be successful on a problem just like that. Okay, those two, there are two diagonals, they intersect in the middle, and it cuts them in half. It's called a bisector. Okay, it literally cuts it perfectly right down the middle. Okay, the last one is, once again, oh man, these last couple of questions are these are so awesome. So just like I said before, opposite angles are the same, and also opposite sides are the same. Okay, those are the same length, just like those are the same lengths. Okay, so n would equal to 9. Okay, and m would equal to 6. And that would be it. Okay, I don't really know what your numbers are. They're probably going to be similar, like 8 and 7, 9 and 6, 6 and 5. I don't know. Okay, just go with the numbers you got and go from there. So that's it. Okay, I'm going to post this video on so you guys can check this out later. Give me a second. All right.